So a lot of times we like to try to start with a simpler version of a problem.
Okay.
So my challenge to you is, can you write down two irrational numbers, so that when you make just one new number by swapping digits, we'll call this new number oval. You write one and you make this number just by swapping digits or just picking digits, like here, 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 here. You know what I mean?
Mm-hmm. Okay.
And two irrational numbers, and you make a rational number by picking the digits. So let's see. Not for pi and e is it specifically possible, but for two numbers, two irrational numbers, is there a way that we could actually invent or make this process work?
Well,
because maybe there's no way to do it at all.
Well, if they're always repeating, they have to have some sort of repeating pattern. This rational number has to have a repeating pattern.
That's right. But these ones can't because they're irrational.
Yeah. So you'd have to kind of pick digits from each of them to make a repeating pattern. But since there's no clear pattern between our irrational numbers, then I don't think you could do this.
Okay. So maybe it's impossible.
Possibly, yeah.
Because you're right. The problem, you've identified the exact problem. We need to have a repeating pattern down here, and we need to have no repeating pattern in either number. But maybe there's a way to create a pattern from the two numbers that doesn't appear in either of the numbers.
Well, like, what happens if your number, like, it could be 0 point something 1 something 1 something 1, where all these are different, or it could have like 0.1 something 1 something 1 something.
Interesting.
Where all of these are different.
And if these digits
fill those in randomly.
had no repeating pattern, and these digits had no repeating pattern.
I think that's possible.
Okay. So what are some digits that you could fill in that you know have no repeating pattern?
Well, like,
if you fill in just, if you all you have to do is so you could just start by filling in randomly. You could just start with well,
the problem with filling in randomly is you might get a pattern by accident.
Oh, you could fill in the digits of pi.
Oh.
So you would start with like 3,
1, 4,
and then 159.
And we could do the same thing here.
You could just fill in digits of pi again, and these numbers wouldn't be the same.
We don't know what these numbers are, but they're irrational.
Yeah.
Right, because we know there's no pattern in these digits. And then what's the new number I form down here?
You form 0.1111 by taking all the ones.
Cool. Yeah, that's a great number. So, we just learned something.
It's possible.
It is possible to do this. Okay? So, it's possible to have two irrational numbers and make a rational number just by swapping the digits. Okay, so now when we return to pi and e,
the problem is you can't just randomly put in ones. There's no you couldn't do what we did for the other one.
no.
But you have to find some, if this was possible, you'd have to find some complex pattern between these two numbers.
Okay. Do you think it's possible for these specific numbers?
I don't think so.
You don't think so?
No.
You don't think so either. Okay. This is a very cool question, and so let's watch Kelsey Houston Edwards' video now. And there's one other really cool thing I just want to say ahead of time. This video has her. It has our friend Joel David Hampkins. Do you remember him? Do you remember some projects we've done with his work?
I think so. I know we've done projects by him.
We've definitely done some projects by him. He made the fold and punch for symmetry project, for example. And actually, he just wrote to me the other day and said he liked that creating equilateral triangles puzzle that we did. So, and then so besides Kelsey Houston Edwards and Joel David Hampkins, Terry Tao makes an appearance in this video as well, and we know him from, do you remember? Yeah?
The 3D printing stuff?
No, not Terry Tao from 3D printing, but from, he did that video at MoMath about pattern, or the ladder in the universe, measuring distance. Do you remember that one?
Oh, yeah.
All right. Okay, good work, guys. Let's go watch Kelsey Houston Edwards' video.